All right, hello everyone. Here's a video of me going through the handout that I gave you earlier in class. I would rather spend the class time working on math and having you practice exam questions for review than for me to stand up at the front of the room going through this item by item. So as I recommended in class, I think watching this video is a really good use of your time. It probably is going to end up only being about 20 to 25 minutes long. This covers everything you need to know in Unit 3, which is Trigonometry Part A. And we start off with the common angles. It is a fact that pi radians is 180 degrees, and that is a fact that needs to be in your brain. You should not be searching for that piece of information. It should be obvious. From that idea, you can construct different ideas. For example, if I take half of 180 degrees, that's 90 degrees. And since 180 degrees is pi radians, 90 degrees must be pi over 2. So I can fit 90 degrees into 180 twice. On the other hand, if I take that angle of pi radians, or 180 degrees, and cut it into 6 pieces, pi divided by 6 means 180 divided by 6, which is 30 degrees. If I cut pi radians, or 180 degrees, into 4 equal chunks, I get 45 degrees, so pi over 4 is 45. And you can continue to apply that idea. Dividing 180 by 3 tells you that 60 degrees is 1/3 of pi, or pi over 3 radians. You're expected to be able to convert from radians to degrees or degrees to radians using either exact values or decimal approximations. If you have a situation where you cannot do that conversion because the angle is not a multiple of one of these common angles, then you can always use the ratio of pi radians over 180 degrees equals, let's just say you're converting 37 degrees into radians. You would have pi radians over 180 degrees equals x radians over 37 degrees. And then you can cross multiply and simplify that to an exact value, or plug the result in your equation, or in your calculator rather, in order to get a decimal approximation. Arc length formula: there's a relationship between the arc length created by a rotation angle in a circle and the radius of the circle. The relationship is that the angle is equal to the arc length divided by the radius. This is on your formula sheet. A is the arc length, r is the radius, and the angle theta must be in radians. So this is the most important aspect of this formula in terms of being successful on exams. You obviously have to be able to solve problems on exams using exact values or decimals, but the bottom line is, when you use this formula, the angle must be in radians. So for example, if you're going to use this formula in a problem on an exam to calculate an angle, and the angle needs to be in degrees, then you would calculate the angle using the formula. You'd say to yourself that that's an angle in radians, and then you would convert it to degrees. Similarly, maybe on an exam, you're going to have to use that formula maybe to calculate an arc length. And you're given the angle in degrees. Well, you're going to have to convert that angle in degrees to radians first before you feed it into that formula for theta. Bit of review from Math 20-1, but it's absolutely crucial in your success in 30-1. A rotation angle on a coordinate grid involves an initial arm rotating through a particular angle to some final terminal position called the terminal arm. If you have that initial arm on the positive x-axis and it rotates in a counterclockwise direction, as is indicated by that diagram, then that's a positive rotation angle. And of course, a negative rotation angle is in a clockwise direction. Reference angles are also something that is important from Math 20-1. What the reference angle is the smallest positive angle between the terminal arm and the x-axis. A reference angle does not have any direction to it. It's just the quickest way to get to the x-axis from the terminal arm. So if the terminal arm is in quadrant 1, you can see what the reference angle looks like. You can see what it looks like if the terminal arm is in quadrant 2. You can see what the reference angle looks like for a quadrant 3 terminal position. And in quadrant 4, you can see what the reference angle is. I want you to notice that in all of these cases, the reference angle has no direction. The rotation angle, on the other hand, has a direction. And I'm choosing to go in a positive direction. I think it's really important when you're solving equations in particular, with a certain type of equation that I will get to in a bit, that you are able to find a rotation angle if you know the reference angle and you know the quadrant it's in. We'll come back to that idea in a bit, but I want to talk about the unit circle first. You need to know first and foremost what the unit circle is. The unit circle is a circle with a radius of 1 unit. That's why it's called the unit circle, but it must be centered at the origin. And the relationship between x and y for any point on the unit circle is that x squared plus y squared must equal 1. And that's because of the Pythagorean theorem. And we looked at this in class. In this particular case, the Pythagorean theorem for a point would be x squared plus y squared equals 1 squared, but 1 squared is 1. One of the most important aspects of the unit circle in terms of putting it into application is that the coordinates of a point on the unit circle are related to the sine of the rotation angle and the cosine of the rotation angle. Specifically, the x-coordinate of any point on the unit circle will always be equal to the cosine of the rotation angle, and the y-coordinate will always be equal to the sine of the rotation angle. Finally, and this is under the heading of unit circle, but if a circle is not a unit circle, but it is still centered at the origin, the equation relating x and y becomes x squared plus y squared equals the radius squared. So in that unit circle formula, x squared plus y squared equals 1. X squared plus y squared is not equal to 1 because the radius is 1. X squared plus y squared is equal to 1 because the radius squared of the unit circle is 1. Don't forget you're squaring the radius in this formula at the bottom of the screen. I think you need to know the coordinates of the common points on the unit circle. These are points where the rotation angle is 30 degrees, 60 degrees, 45 degrees, 90 degrees, or any multiple of any of those. Knowing those coordinates allows you to determine exact values of a particular trigonometric ratio. For example, and we've got lots of examples that we do in class. I'm not going to give you written examples in this video. If I say to you, what is the exact value of secant of 7 pi over 4 plus cotangent of negative pi over 6, there's no way you're going to be able to determine the exact values unless you're familiar with those points on the unit circle. In addition, when you're solving trigonometric equations, knowing the coordinates of those points allows you to solve the equations a lot quicker. And I would go so far as to say a person who is familiar with the coordinates of those common points on the unit circle will be a lot more successful at solving most trigonometric problems in this course. I'm not going to go through all 4 quadrants in any great detail, but I just want to remind you of how you can determine these coordinates. The 4 points, by the way, from the bottom of the screen going up to the top left of the screen are 0 radians, pi over 6 radians, pi over 4, pi over 3, and pi over 2 radians. You should know that any point that is at that 45-degree reference angle is at root 2 over 2, comma, root 2 over 2. Of course, if it's in a different quadrant, x and y might be negative. One of them might be negative, or both might be negative. The other 2 angles, specifically in this diagram, the pi over 6 and pi over 3, you know or should know that the coordinates are 1/2 and root 3 over 2. The question is, which is which? Well, if we take a look at pi over 6, and I extend a line from that point over to the y-axis, Does it look like that line is cutting the y-axis in half? Well, yes. It's cutting the radius of the circle in half, and the radius is 1. That means the y-coordinate is 1. On the other hand, the x-coordinate, if you look at it, is very close to 1. And we've done this calculation in class. You should know, or remember anyway, should be familiar to you, that root 3 over 2 is approximately 0.8 or 0.9. So it's very close to 1. And you can apply this idea to find the coordinates of any point on the unit circle. And once again, I'm not going to go through the details here, but you need to know that the x-coordinate is the cosine of the rotation angle that takes you there, and the y-coordinate is the sine of the rotation angle that takes you there, so that you can solve problems. And without knowing those facts, you cannot solve the problems. On the coordinate grid, the primary and reciprocal trig ratios are defined in terms of x, y, and r. In Math 20, you were given these on a formula sheet that sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x. And this year, we're expecting you to memorize them or to know them. The reciprocal trig ratios, each of the primary trig ratios has a corresponding reciprocal trig ratio. So the reciprocal of sine is cosecant. The reciprocal of cosine of theta is secant of theta. The reciprocal of tangent of theta is cotangent of theta. So if you know that sine of theta is y over r, then all you have to do is reciprocate that fraction and get cosecant is r over y. If cosine of theta is x over r, then the reciprocal, which is secant theta, is y over x. If tangent of theta is y over x, you get the idea. The cotangent, which is the reciprocal, would be x over y. And you can determine a missing value in that trio by using x squared plus y squared equals r squared. Of course, if the point is on the unit circle, you can just use r equals 1. In the handout I gave you in class, I believe it said x squared plus y squared equals 1 squared. It should say x squared plus y squared equals r squared. Once again, if the point is on the unit circle, then all 6 of these trig ratios, the primary and reciprocal, can be found by just using r equals 1. In other words, they can be determined by looking only at the value of x and y. Additionally, if you get the exam sweats when you're working on some of this stuff and you forget which reciprocal goes with which primary, you can always go to your formula sheet, and these, we call them identities, are on your formula sheet. Whenever you're working with these trig ratios, I want to go back and just show you these 6 trig ratios. Sometimes you need to find a missing value of, say, y. And when you solve that x squared plus y squared equals r squared, by putting in some number for x and some number for r, and you rearrange it for y squared, you're then going to be tasked with taking the square root to get y. But of course, we learned last year pretty early on in Math 20 that when you take the square root, you have to consider the plus or the minus square root. Well, sometimes it's plus or minus, but sometimes it's plus and not minus. And sometimes it's minus but not plus. You're going to know which it is by looking at your coordinate grid and the information in the question. Now, this is a little overwhelming, but I just want you to remember that since x and y can be positive or negative on the grid, r is always positive, by the way, then sine, cosine, or tangent, and consequently cosecant, secant, and cotangent can be positive or negative as well. So it's very important that you look at questions carefully and make the decision as to whether the trigonometric ratio you're talking about or the x or the y coordinate you're going to use is positive or negative. Becomes really crucial when finding values of trigonometric ratios and also when solving trigonometric equations by taking a reference angle approach. And we'll talk about that in a little bit. Speaking of solving trigonometric equations, to solve what we call a linear trigonometric equation, you essentially rearrange the equation so that you have the trigonometric equation is equal to some value or some number. You identify the quadrants that the terminal arm is in. So, if you have sine of theta is equal to negative 0.2, since sine is negative, you will be looking in quadrants 3 and 4, where the y-coordinate is negative. This is what I was referring to a minute ago. You then use your calculator to find the reference angle. When you do that, you never take the inverse sine or the inverse cosine or the inverse tangent of a negative number. You simply go inverse tan of the absolute value, or inverse sine of the absolute value, or inverse cos of the absolute value of whatever the trig ratio is equal to. Once you've identified the quadrants and you've got the reference angle, you sketch that reference angle in each of the quadrants. There's usually 2, but not always. And then you use your sketches to determine the rotation angles. Or, if the trigonometric ratio is known to you, so if you're dealing with something that says cosine of theta is negative root 3 over 2, then you should be able to go to your unit circle and identify the 2 positions where the x-coordinate is root 3 over 2, negative root 3 over 2, and use that to determine rotation angles. Again, this video is not intended to be a complete review. This is here to remind you of everything that you've done. You need to dig deep. Go back in your notes, go back in your examples, look at the review problems, and find problems that are involved in this particular unit. Find problems where you're solving trigonometric equations using either of these methods. Moving on, if you have a quadratic trigonometric equation, basically you factor it and set each factor equal to 0. When you factor a quadratic trig equation, you're going to get 2 linear factors, and that's going to take you back to the top of the page where you're solving linear trigonometric equations. Finally, we looked at graphs of sine and cosine functions in this unit. The base sine function, the starting point for y equals sine of theta, looks like this. It has a start point in the middle, specifically at the origin for this graph, and it's going up. It has a period of 2 pi. It has a range from -1 and including -1 up to and including +1. You ought to be able to figure out or know or tell me what the y-intercept is and what all of the x-intercepts are. And you need to repeat that process. You need to become intimately familiar with the graph of y equals cosine theta, which, by the way, has a start point at the top. I think you should understand that both of these equations produce graphs that are identical other than a phase shift. If I were to take y equals sine of theta and shift it pi over 2 units to the left, I would get y equals cos of theta. If I were to take y equals cos of theta and shift it pi over 2 units to the right, then I would get y equals sine of theta. When we apply the transformations from Unit 1 that we learned about, a, b, h, and k, to y equals sine of theta or y equals cos of theta, this is what we get. Of course, we don't use h, we use c, and we don't use k, we use d. So these are the equations of the transformations of the 2 most basic trigonometric functions, and you should be able to look at a graph and tell me what the amplitude is and figure out what the period is. Because quite often you have to come up with the equation. So first of all, the amplitude will lead you to what the parameter a is. If you can look at the graph and see the distance from the middle of the graph to the top is 10, then you know the amplitude is 10, and that means that parameter a is either 10 or -10. The vertical displacement is essentially where the middle of the graph is vertically. So if you have a graph that has a maximum of 100 and a minimum of 50, then you should be able to reason out that the vertical displacement is halfway between 50 and 100, which is 75. The phase shift is c. We'll come back to that in a second. And the period of the graph is related to the parameter b by period equals 2 pi over b. Or if you want to work in degrees, I guess you can from time to time. Period equals 360 degrees over b. Most often you use that formula. That's not true. Very often you use that formula not to find the period. Instead, you look at a graph to determine the period and then use b equals 2 pi over the period to get the parameter b. Once again, the midline, just another way of saying vertical displacement, is the value of d. The maximum value of the function will be the vertical displacement plus the amplitude, and the minimum value will be the vertical displacement minus the amplitude. Finally, if you're trying to come up with the equation of a trigonometric function from a graph, leave c to the end. Determine a and d by looking at the vertical positioning of the graph. Determine b by looking at the period and using b equals 2 pi over period. And then determine c by writing out your equation with just no c and graphing it and seeing if you can figure out how much to shift that graph to get what you're after. If that's not possible, write out your equation with a missing parameter of c and load in an ordered pair and solve that equation. I hope that's helpful. Once again, a reminder, this is not a video that's going to answer all your questions. This is a video to get you going on the right path to doing better on the exam coming up. You need to, as I said, dig deep in this unit. You need to do every single review question that I give you if you want to do better and better. So I hope that helps. I hope you have a great night, and I will talk to everybody soon.